Let's learn about the hybridization process in ICl2-. First, we already have our Lewis structure of ICl2-. Next, we determine the electron groups at the central atom. Look at I. So we have 1, 2, 3, 4, 5 electron groups. Electron group is 5. And when electron group is 5, hybridization is sp3d. Right? Next, this structure involves I, which it have valence electron for I is 5s2, 5p5. And in this structure, we also have Cl, involve Cl with 3s2, 3p5 valence electron. Next is types of bond. So in our structure, from the Lewis structure, we can see that our structure has 2 sigma bonds and 3 lone pairs. From the structure, 2 sigma bond and 3 lone pairs. Alright, now we will start our hybridization process. First step is ground state of our central atom. Okay, now take note, this structure is an anion with negative charge. So our central atom is I. If your structure, if your compound is an anion or ionic compound, so we have to consider the formal charge of the central atom. Look at I here. Let's calculate the formal charge. 7 minus 6 minus 2. 7 minus 6 minus 2. So it is negative 1 formal charge of I in this structure. So when come to hybridization process, we will write it as ground state of I minus. So I minus means this iodine already accept 1 electron. As a ground state of I is 5s2, 5p5. So for I minus, it has become 5s2, 5p, 1, 2, 3, 4, 5, 6, 5p6. Next step is promotion of electron. Now, we have, in this structure, we have 2 sigma bond and 3 lone pairs. Refer to our previous video. Sigma bonds need 2 single electron. 3 lone pairs need 3 pair electron. Now look at our ground state of I minus. We need 3 pair electrons for our lone pair. So 1 pair electron, second pair electron, third pair electron. And now we have 2 sigma bond, which we need 2 single electron. Okay, class. Now, when we want to make it single electron, so we have to promote this 1 electron to another empty orbital. So 5s, 5p, actually here we also have empty 5d orbital. Okay, so ground state of I minus, we have 5s2, 5p6 and empty 5d orbital. We will use this empty orbital in our promotion of electron, where this electron we will promote to this empty orbital, and we will write it as 5s2, Okay, this one for our first lone pair. This one for our second lone pair. No, this one is first lone pair, second lone pair, and third lone pair. First sigma bond. This is for second sigma bond. Okay, and last step is sp3d hybrid. Means S plus P plus P plus P plus D. So we just mix all these 5 orbital diagram. sp3d. Okay, now this first orbital we have paired electron for our first lone pair, second paired electron, third paired electron, first single electron, second single electron. These 3 paired electron for our 3 lone pairs. These 2 single electron for our sigma bond. 2 sigma bond. So we only use one 5d orbital here. So we have remaining 4 orbital d. So we just write it. So left here is 4. And write it as empty 5d orbital. Okay, so finish for the hybridization process for ICl2 minus. Let's recall. Starting with Lewis structure, we determine our electron group. From electron group, we can know our hybridization, our types of hybridization, and we have to know the valence electron involved, iodine and chlorine. From the structure, determine types of bond and determine either the structure has lone pair or not. So from our structure, we have 2 sigma bond and 3 lone pairs. So that we can start our first step in hybridization process. Write the ground state of I minus. Why I minus? Because our structure now involves anion, and we have to consider the formal charge for the central atom, and it already accepts 1 electron, so 5s2 5p6. And remember, we also have empty 5d orbital. For the promotion of electron, we need to promote 1 electron here, and we have to leave 3 lone pairs in our orbitals because we have 3 lone pairs in our structure. So kita akan tinggalkan ini 1, 2, 3 pair elektron kita tinggalkan. 1 electron will be promoted to F5d anti-orbital. And last step is sp3d hybrid. We mix S 3p orbital and 1d orbital and left empty 5d orbital like this. Okay, so settle for the hybridization process of our ICl2 minus.